Take a moment to pause the video to read the setup of this problem. What you're going to find is that we're going to use a graphing utility to help us fit an exponential function to the data given. I'm choosing to show this with Desmos. So the first thing I did here was type the data into a table. And by the way, if you forgot how to add a table, if you come up here to the plus sign and table, you can add a table to the space. And notice the points are already plotted here. I see them as I was typing them in, even I saw them appear on the screen. You could move around your graph or zoom in. For instance, you could do that if you'd like as well. But I need to use this particular model, y equals a times b raised to the x. So to do that, to find that model, I would do y1 tilde a times b raised to the x1. Always select log mode. It may give you slightly different parameters, but log mode is what's used on the TI-84 automatically. Desmos just has that additional step that you need to do. And you see here those parameters. If you ever need more detail about those parameters, more digits or decimal values, you can come down here to the next line and type that parameter, and you can see I can get more detail that way. But I'm going to take those values and type them in to my other screen. So I did that here, typed in those parameters in the form they were given, and that was accepted. For this next part, I'm going to try to do Desmos again. Let's run another regression, but this time let's use this particular form. In this case, I really don't need the subscript. That's just part of the form, I guess you could say, that we use when we write it by hand, but I don't believe Desmos will need that particular subscript. So this is what we'll do. We'll still refer to y1, that's referring back to our table of values, and we'll use tilde. Instead of n sub 0, we could use a, for instance. Well, actually, you know what? Let's don't use a since we used it in the previous one. We'll say c, just come up with the next parameter, and then times e raised to the kt. Let's try that. So c e raised to the kt. Well, k times x, I guess I should say 1, because x1 refers back to the values in that table. I always click log mode, and that gives us these parameters here for the coefficient of the entire expression and then the coefficient of that exponent piece there. So let's type that into the other screen. So you can see I did that here and it was accepted. I just, again, make sure that you're using the same variables that the problem in Pearson's using. So in this case it used t, so I made sure to put t. For the next part, we're looking for a graph. And it's nice that we're using Desmos because that graph is automatically displayed. And again, just matching, going back and forth between the Desmos screen, you should be able to match. You might want to click on these little plus signs just to kind of increase the size a little bit to see them better, or this pop-out window to see the graph better, because they are very similar. I have to really match it. And then for this next part, use the exponential function from either a or b to predict the population at x equals 7 hours. So I can come back to my Desmos screen. I can just click and drag here until I get to x equals 7, and I see that the output is 1.32. So y is 1.32. And then for the next one, use the exponential function from either a or b to predict when the population will reach 1.35. So let's see if I have enough on my screen here to see that. I'm just clicking and dragging on that line. I'm looking for when y is 1.35. Okay, I'm not exactly on it. So if I need more precision, what I could do is I could come down here to the next line and type y equals 1.35. And then click on that point where that point of intersection occurs. And that happens at x is 7.078 or 7.08.